present a single-session user study exploring the advantages of graphical cues and precues in AR for sequential rotation tasks. A cue indicates the current step to perform, while precues provide information about future steps before the user performs them. We extend this line of research by investigating whether and how much pre-cued rotation information can improve user performance. We consider two unimanual tasks. One requires a user to perform sequential rotations of a single object, and the other requires a user to move their hand between multiple objects to rotate them in sequence. Each of these two tasks consists of multiple steps, and in each step, the participant needs to rotate a designated object by a designated angle about the vertical axis. We use a circular arrow for each rotation cue and precues to guide users to rotate objects. For the single object task, the rotation precues are concentric with the rotation cue, are located further from the object, and have darker colors. Their heads and tails do not follow as the object rotates. For the rotation cue, the end of the arrow tail follows the object's orientation when the user rotates the object. The base of the arrowhead indicates the goal orientation and does not move when the user rotates the object. In each step, the user needs to rotate the object to make the tail of the rotation cue align within the 15-degree acceptance angle of either side of its head. Upon completing the step, the first precue becomes the cue. Its color becomes brighter, and its radius becomes smaller. The other precues also update in their colors and radii. The next step following the steps already precued is added. This process repeats until the user finishes the task. For the multiple object task, the user needs to move to a new object and rotate it in each step. The rotation precues work the same way as the ones used in the single object task, with one exception. They use the same radius as they will not overlap since only one rotation visualization appears on an object at a time. To guide the user to the objects, we use a movement cue and precues. The movement cue is a yellow line from the user's hand to the current object, while each of the movement precues is a cyan line connecting an object to the next object to be rotated after it. Our study has three parts. In Part 1, we examine the impact of rotation precuing visualization styles on step completion time in a single object task. We consider four styles. In the unhighlighted style, the arrowhead and arrow tail are not highlighted. In the head highlighted style, the arrowhead is highlighted by being replaced by a thick gray segment centered about the base of the head. In the tail highlighted style, the arrow tail is highlighted by being replaced by a thick green segment centered about the tail. In the head and tail highlighted style, the head and tail are replaced by a gray segment and a green segment, respectively. We tested a rotation cue with 0 to 3 rotation precues. For all styles, performance, that is speed, improved when the first precue was added. With 2 or 3 precues, there was a small but significant improvement in several cases, and the performance did not become worse in other cases. Average across all number of precues, the participants performed the fastest with the head and tail highlighted and the tail highlighted styles. In Part 2 of the study, we compared two approaches to align the cue and precues of the head and tail highlighted style in the single object task. In destination origin alignment, we align the destination, that is the head of a cue or precue, with the origin, that is the tail of the next precue. In origin-origin alignment, we align the origins of the cue and all precues. Participants performed best with destination origin alignment for any number of precues. In Part 3 of the study, we explore whether participants can use rotation precues in conjunction with movement precues in the multiple object task. We compared two conditions, rotation cue only and rotation cue and precues, where each movement precue is accompanied by a rotation precue. In rotation cue only, using one movement precue improved performance, and performance did not become worse when additional movement precues were added. In contrast, in the rotation cue and precues condition, performance improved with one rotation precue and movement precue, but was not better than rotation cue only with one movement precue, implying that the rotation precue was not helpful. When more rotation and movement precues were used, performance deteriorated and was not better than when just the rotation cue and movement cue were used. In summary, participants benefited from rotation precues in a single object task, with some styles and alignment approaches performing better than others. In contrast, rotation precues were not beneficial in the multiple object task. However, the first author who had used the system extensively during development routinely performs better with a single rotation precue. This implies that a longitudinal study might show advantages for rotation precues in the multiple object task. To learn more, please see our paper.